In math, we can convert a system of linear equations into a matrix. A matrix is a rectangular array or a table of numbers arranged in rows and columns. The plural of a matrix is called matrices. So, if we have an m by n matrix, where m is the rows and n is the columns, it has this following form here. This is what a matrix will look like. Now, if you're confused by the ones and the twos and the reds and the greens, that'll all be explained in just a second. We say that the matrix has dimension m by n. The numbers a sub ij are the entries of the matrix. The subscript on the entry of a sub ij indicates that it's the ith row and the jth column. So if we have here a sub 11, a sub 11, we say this is row 1, column 1 for this entry. This is row 2, column 1 for this entry, row 3, column 1 for this entry, and so forth. This is row 1, column 2, row 2, column 2, row 3, column 2, and so forth all the way. Doesn't mean that the matrix have this many elements, it just means that it has this form, running left to right and up and down. So, when we write a system of linear equations as a matrix, it is called the augmented matrix of the system by writing only the coefficients and the constants that appear in the equation. So, how does that work? Let's take an example here. We have this system of linear equations of x, y, and z, and we're going to write this in an augmented matrix. So first I'm going to write out my little bracket, well, kind of a bigger bracket, and I'm going to start off with the first equation and write the coefficients. So we have a 3, a -2, a 1, and a 5. So 3, -2, 1, and 5. And I will cap the matrix off there. Now I'm on to the next one. 1, 3, -1, 0. So 1, 3, -1, 0. And then here I have a -1 missing a y, so that's just an automatic 0, a 4, and an 11. So -1, and again we're missing y, so I can say that the coefficient is 0, 4, and 11. So this is the augmented matrix, and sometimes, not always, but sometimes you'll see a line drawn right here, and it kind of like emphasizes that this equation is equal to this equation is equal to that, and so forth. It's not always, but sometimes they do that there just so it can keep track of what's what within the matrix. But this is an augmented matrix from this system of linear equations.